how do we actually make the connection between LLMs and enterprise data, right? And for that, we have Nils Reimers, who is the Director of Machine Learning at Cohere. Nils, the floor is yours.
Thank you so much. Great to be in person here, mostly nowadays virtual presentations, so it's great to be in person again. Let me check. Okay, so I want to keep it short. We heard a lot about RAG, and I want to go into like how far are we with search? So a lot of people are interested in search and see, okay, it's amazing, it works well. Use semantic search, use a vector database, and it solves all your problems. We already heard in the previous talk, it's not always the case. Context length is one problem, but there are like a lot more fundamental problems. But this opens a really cool research perspective to go into search. So we're really in the beginning of search. Search totally sucks. It's not working well. But there's a lot of room of improvement, which gives people research ideas and opportunities to work. So at Cohere, we focus on two models. One is generate model. We all know, give an instruction in, generate the output. I'm in charge of text understanding, so I'm not producing any new text, but I want to understand what's written in the text, either for classification or other big use cases search. And then we already heard the RAG. So customers come in and say, yeah, with ChatGPT, I can get an essay about the French Revolution. But if I ask ChatGPT, hey, what's the status with this customer? Says, sorry, I have no idea what you talk with the customer. So I somehow need to connect it to Salesforce to get the information, what has been discussed. And this is basically RAG. So it's easy. You ask some question, you have some enterprise APIs, use different search systems, plug it together, and then you do really easy prompting where you say, this is a question, that's a context, here are 3 documents I found, and then it gets you the answer. However, as usual, garbage in, garbage out. So if you put garbage here in the context, the model has no idea how to answer it. If it's a generic topic like French Revolution, it still can learn it from internal knowledge. If I ask stuff about, hey, how is the negotiation going with this client, and I put garbage in here, which is, yeah, maybe outdated, not relevant, it's producing garbage out, and there's like no way how the model could solve this. So inputting the right information here is extremely critical. So we all know these semantic vector spaces. So we have a nice vector space where we cluster information based on the semantics, on the meaning. So we're not looking at keywords. So even such that TensorFlow and PyTorch are completely differently written. We know TensorFlow and PyTorch, that's quite similar. Here I say deep learning library, here I say machine learning framework. So this works quite well where we put in different stuff depending on the meaning. So here's about deep learning, here's about founder of Facebook, here are bananas, Albert Einstein, and different atoms. And then a query comes in and says, okay, who's the founder of Facebook? I also put it in the vector space. And then I find these 2 entries and I either give it as top 10 results list and say, okay, here are 2 entries I found, or I do the rec style and put it into the generative model. And the generative model is like, yeah, paraphrasing this and telling me Mark Zuckerberg is the founder of Facebook. So now I want to talk about shortcomings of semantic search. So this is like what a lot of people hyping and say, okay, that's amazing, you need to do this, it will solve all your search problems. But actually, search is a lot more complex than this. So this is nice, but there are so many things which can go wrong here. One challenge is retrieval on noisy data. So most existing models, they just measure only on the topic match. So you have a query, and then there's like 2 documents. One is low quality document, the other is high quality document. They just measure the topic similarity of these using cosine similarity, say, okay, this has like a nicer topic overlap, so I return this, while the high quality document has less topic similarity, and so it's not found by cosine similarity. And that's a problem if you either use the rec style or if you use like top 10 list, doesn't matter. So for example, if you ask OpenAI about COVID-19 symptoms, and then it gives you as an output, first entry is COVID-19 has many symptoms, COVID-19 symptoms are bad. And the third entry is about COVID-19 is a disease caused by a virus. The most common symptoms are fever, chills, and sore throat, but there are a range of others. So this one, which is for the user the most informative, is actually put at the last place. Because the other two, they are like on the topic match much closer, like COVID-19 symptoms. COVID has many symptoms. That's like on a just topic match, super, super relevant. Here we have like other topics like what's COVID-19, how is COVID-19 caused? So this is disturbing for the model. So, and that's kind of bad. So either if I show these, let's say I just pick like top 2 and show it to a user, they say, okay, what's this? I asked you like, what's COVID-19 symptoms? It's not really helpful that it tells me it has many symptoms. If I put it into a generate model, it's also not able to produce any sensible output. And so a big project we did recently is how to work better on noisy data. What you need to measure is like not only the topic match, but also what's the content quality. Is it like low quality, not really informative, or is it like really, really informative? And a nice approach here is to not just like cosine similarity and measure the topic similarity, but encode it in the magnitude of vectors. So basically if it's like low quality, you encode it as a short vector. If it's a high quality, you can encode it as a long vector. And then if you measure both the angle and the magnitudes of it, you see that the quality, the output is much, much better. So it sees, okay, this has like a lot of information. It's not super 100% on the topic match, but it has a lot more qualitative content. So it's putting this information at the top position. And there's a big difference on noisy data. If your data set is nice and clean, and a lot of academic benchmarks are nice and clean, super well created, maintained, there's like no noise in it at all, you don't see a big difference. But in reality, it gets messy, and it gets messy really quickly. And then you sit there and think, okay, how does it work? And a nice data set is the track COVID-19 data set. It's a crawl of COVID-19 papers by LLM. And when you crawl data from the web, it goes wrong. So sometimes some data is nice, but in this, like about 25% of the data in this collection is noise, where they get like an incomplete crawl. So they don't crawl the full paper in this case, but just crawl the title, which basically has no information. So if you ask like, what are COVID-19 symptoms? Maybe there's a paper on like COVID-19 symptoms documents, but that's it. It just mentions common symptoms of COVID-19. And then the rest of the document is missing. So for this data set, it's really easy to measure quality. Is it noise or not? And what you see with a lot of models, previous models, that's not taking quality of content into account. It's retrieving like 50-50 quality and non-qualitative content. So for 50% of the queries, it's just noise and garbage. And for the other 50% of the queries, it's not working well. And so this has been a big project we're working on, how to include like not only like the topic match, but also the quality of the content into the vector, where obviously the question is like, okay, how can I estimate the quality of the content, and how do I map this into like the magnitude of the vector? So where we're using basically a bigger model, stronger model that's measuring, giving a query, how qualitative are these different? And then using distillation approaches to transfer this knowledge and say, okay, this here has a really good, really high quality content. This has low quality content. So adapt the vectors for these respectively. My main fan topic on embeddings and where they go wrong is multi-aspect data. So originally I called it sentence transformers, and back in 2019, people, or 2018, just use it for sentences. But then eventually IR community said, yeah, embeddings are cool for longer documents. But it's like, does it really work for longer documents? It's super hard. So if you have a short text, it looks nice, but let's try to go like to 2 sentences. So if I have a sentence, a paragraph like hydrogen has atomic number 1, helium has atomic number 2, I encode it, get an embedding, the embedding is here, say, yeah, looks good, works well. But now a user puts in something crazy, says, okay, here's my Notion page, random facts I care about. And they write something like this: bananas are the most sold fruit. Facebook was founded by Mark Zuckerberg. Totally valid. People can write it. There's no rule, no law prohibiting this. But then if you put it in a vector database and you search for, hey, what's a good framework for deep learning? You as a response get bananas are the most sold fruit. Facebook was founded by Mark Zuckerberg. And then if you paste it in RAG, which make it even worse, says, hey, I can recommend to use bananas. It's the most sold framework for deep learning. You should use it. It was created by Mark Zuckerberg. And you say, yeah, that sounds good. So if you link it back to the sources, you're still wondering, okay, why is this popping up as a response? And the issue is, if you take this text, bananas are the most sold fruit, Facebook was founded by Mark Zuckerberg, there's no good space to put it in the vector space. So if you encode it here, you can find it when you search for bananas or sold fruit, but you will not find this document for founder of Facebook. If you encode it here, you're not finding the information what's the most sold fruit on the world. So for the model, it makes sense to put it in the between, but in between there's something else. So the space is not empty there, it's taken with information on deep learning. And yeah, it's really problematic. And the bigger your data set gets, the harder it gets. Also, the longer your documents get, the worse it is. So in the previous talk, we mentioned BERT has like 512 token length limit. It's now solved with flash attention. We can scale it up to like 10,000, 100,000 of tokens. But if you have like a really long document, let's say 100,000 tokens, is it really just on one thing, just iterating? I don't know, Facebook was founded by Mark Zuckerberg over like 100 pages. Probably not. Probably it has a lot of different aspects. And as soon as you have different aspects, the vector space becomes garbage and useless, and you can't use it. And it runs really interesting. So here's an example on papers from arXiv, 200,000 machine learning papers, or no, so this is 2 million papers from arXiv. Really simple question: when was attention paper by Aidan Gomez published? I get the top 3, and I like, what? Withdrawn. The paper has been withdrawn. Comment on article by Ferrari and introducing the discussion paper. Nothing to do with Aidan Gomez, nothing to do with the attention paper, not even close to like deep learning. Again, it's the problem of these multiple aspects. So Aidan Gomez, that his parents decided 30, 35 years, I don't know, 30 years ago to name him Aidan, has no connection to the attention paper. So he could call him John or Lucas or Michael. And then I would search for, hey, what's the attention paper by Michael Gomez? And that's a problem. So we have like the authors in here, Michael, Peter, which are like all semantically independent. They are like different aspects. We have the date that this was published on Wednesday, September 16, but authors, yeah, maybe they could have published it on Tuesday, September 15. So there's not really a semantic connection that comment on articles by Ferrari must be published on Wednesday, September 16, 2015. And so what we did last year is produce a model, re-rank, that can transform these really shitty documents. So we saw it in a lot of use cases and give you a nice output. So you take this, map it back, run it through the model, and then does like give you at the first entry attention is all you need by Aidan Gomez, and you get these nice results from it. It's not using embeddings. So embeddings can store one fact. It's based on like a multi-vector approach where it says, okay, let's go in and find like all the aspects which is mentioned here. So the title is one aspect, all the authors are different aspects, the date is an aspect, the abstract and all the tokens in the abstract is an aspect, and then looks in the title, what are the aspects? So one aspect is attention paper, second aspect is Aidan Gomez, third is like when was it published, and then does like a matching of like all the aspects in the query to all the aspects in the document to give you at the end the best results on this, which gives you really, really good, promising, nice results when you have like a bit more complex data and you can't control like what's in your data collection. So that's my standard example. If you do an interview with me to motivate it, I say, hey, you open up your Gmail, they implement semantic search. You ask a question, hey, at which time is my flight going? It finds an email like this, ready for check-in. Your flight is ready for check-in, be at the gate at 4:30, takeoff is at 5 p.m. I run it through generative model tells me, yeah, your flight be at the gate for 4:30, traffic is heavy, you should catch the Uber at 3 p.m. and go to the airport. Say, yeah, great. Order an Uber, put it into the action. I come there and see my flight is gone because I got the email on August 3rd, 2010. So it's completely useless. I mean, the flight is long gone. It's like 10 years, 13 years ago. It's not really meaningful. So I'm not interested in like at which time was my flight in 2010, but at which time is my flight, for example, tomorrow going home. So this is like really, really hard in these vector spaces to get right. Another aspect, which is quite relevant, is how to model authority. So it's not only relevant what you're saying, but it's also saying who is saying that. So is this some random dude, or is this like a topic matter expert? So if I ask for, why is it not? I think I broke the projector. Okay, now it's working again. So for example, I ask question, what is the company focus? What is the company focus of Facebook? For example, you run it over your internal Slack, email messages, whatever documentation you use in the enterprise. You got two results. One is like Facebook should focus better on photo sharing option with friends. The other is metaverse isn't a thing a company builds. It's the next chapter of the internet overall. Say, yes, semantically, this is better. So here it's talking about Facebook, about focus. So here's a better semantic match, gets ranked higher. It goes into my generative model. And then my generative model says, based on the information I got from all your company enterprise data, you should focus as a new person to produce better photo sharing options in Facebook. But the story changes if you see who wrote this. So this is maybe a statement some random intern wrote in the first week. And this is a statement from Mark Zuckerberg from the CEO. So obviously, Mark Zuckerberg, CEO, founder, beats like any random intern or so on. So you can disagree what like company focus on and if metaverse a sensible thing or not. But typically, if the CEO says, okay, this is our focus, it makes sense to listen to that and not necessarily listen to a random intern or not from the first week. And that's like really, really hard to model. Like how can we take this into account? Like who's saying this? Like if you think about like vector spaces, embeddings, there's like no way. How can I say, okay, this is stated by the CEO. What do I do with the vector? Do I do it closer to my query? But how do I do it? It's like just on the semantics, but it's not like who said this. And so that's like completely unknown fact. I think no one really in IR community has a good understanding yet. How can we include it to not only search over like what was said, but also who said it and how trustworthy is the source? And to summarize, noisy data. So this is kind of like solved, I would say, to some degree by our embedding model, by taking like content quality and magnitude into account, and by re-ranking approaches, multi-aspect, that's also really works well with these multi-aspect re-ranking approaches. What's interesting, what we're working on, is out of context information. So you have a paragraph mentioning our biggest challenge this year. You ask like, yeah, what's this year? So how should you derive a good representation for this? Is a company? Is it a person? Is it a society? Same with GPT has challenges with hallucination. If you don't know what GPT is, how can you answer it? So if I say, what are challenges for LLMs? How can I make the connection to GPT? So we know it because we read it multiple times. But when it's like new information, someone comes up with a new acronym like Falcon, yeah, how do we put it into the model? So none of the models know that Falcon is a new 180B open source model. So if someone says Falcon have issues with hallucination, okay, we think about the bird and think, okay, why do they do drugs, or why do they have challenges with hallucination? Temporal popularity and authority signals, so really difficult to model. So like in emails, how do I really find that one email telling me about the flight I care about, which is the next upcoming flight. So this is like really, really hard to find in my email inbox because I have hundreds of flights, hundreds of flight emails. But what's the one email I care about? What's the information, the up-to-date information about my next flight? And how do you learn effectively for your enterprise the hierarchy and expertise? So who's the manager, who's the boss, who's the CEO, or who has like a lot of expertise on a topic? And we know, okay, if this expert, if John says, you should use Python for X, we know, yeah, John is really good at that, so I should listen to it. But if there's some random person from, I don't know, marketing or whatever department say, yeah, we should not use Python for this, you judge it differently. And it's kind of challenging. And final one, multi-query. If I have a question, how did the number of employees change for FANG during COVID? This is unlikely to be found in a single document. But how can I find this information? So for us humans, it's an iterative process, so it's not a one shot. So maybe I put it in Google, I find the information because someone wrote a Medium article about it, say, awesome, I can stop here. But then we can do a backtrack and say, okay, oh yeah, we're not finding it in one article. So maybe I search for like Facebook, how did the number of employees change during COVID? Maybe I don't find it even then. And then I go into like, how many employees did they have in 2019? How many employees did they have in 22? And only then I can say, okay, now I can make the call, go to the next company, do it for all the 5 companies mentioned in the acronym. And then at the end, I can write you a nice summary and rack and say, okay, this is how the employees change for these companies. And it's really hard how to model it, how to search for it, and how do you do these iterative process. And that's from my side. Thanks so much. And hopefully, yeah, some thought-provoking ideas.
Thank you so much, Nils. Do you guys have any questions to Nils? Please see Nils over there.
Hi, thanks for the great talk. How did you embeddings the noisy data? How does it learn that the magnitude has to do with the quality and also do you have ground truth for that? This is a noisy sentence, not a noisy sentence that you map like magnitude on that in a supervised learning matter, or?
Yeah. For this data set, it's luckily easy to see what's noisy or not, because there are just one source of noise. Either they can get the full paper and the full information, or they were just able to get the title of the paper. Obviously, in production, it's a lot harder to say what's noise, what's not. On the learning, it's basically, so it's a distillation approach. So very well-known, common in information retrieval. You take a bigger teacher model. So here we teach the model to say, okay, give me an estimate, like, is it relevant or not? But also like how relevant, like what's the quality on it? And then the embedding approach mimics this. So it goes in, sees the 3 examples before, and then says, okay, which of these, which of these has the highest quality in it if presented these 3. And then from the teacher model, it learns and bakes this into the vector space in terms of the magnitude.
I was wondering, you said, so kind of embedding document quality into this vector space is kind of possible in this way, but authority is kind of an open question. So what would be the difference between these 2 things?
Yeah, in theory, you could also put authority in it. The challenge is, how do you learn who's authoritative? Like, for public figures, we know Mark Zuckerberg, Facebook, that's clear. But for any company, how do we learn who's the CEO? And also authority, it's not a one-dimensional thing. So if we think about a company, we know they're like on one side, like authority from hierarchy. So this is like CEO, VP, and so on, my manager. But also in terms of topic matter experts, where we say, okay, this person has a really good understanding of databases. So this person should be trusted on databases. And how do you learn this? And how do you put this in the vector space in an efficient way to say, okay, John, he's an expert on databases. As soon as there's a database question, I retrieve content from John. If you have this training data, you can learn it, but you never have this training data, sadly.
So in a way, kind of using one dimension to adapt the magnitude is possible, but once you have multiple things you want to put in there, it's really a challenge.
Yeah. Thank you for a great talk. I'm wondering about vector, basically, like we representing with a point any semantics. Is it fundamentally wrong? Because there's so many ways for things to be similar, and we're putting the thing in one spot. Is that a problem?
Yes, so I had it at lunch with Bob from VV8 talking about a lot of people search for what are companies similar to X, like what are companies similar to Hugging Face. And that's like, can have multiple dimensions, can be companies doing similar thing, working on open source and AI and machine learning, but can also mean companies that are similar in terms of company setup, like remote first, globally distributed, can be on the history of the founders. So these embedding spaces, they are like really focus on one aspect to say, okay, if I ask like which companies are similar to Hugging Face, it's just pointing it to like one aspect, say like similar products. But of course, humans are a lot more diverse on this, and you can ask like similar companies can also mean similar history, similar work style, similar tech stack, and so on. And that's a challenge as well, especially in recommender systems. It's a big problem. You have the same problem. So on Netflix with my kids, I watch Paw Patrol. It's somewhere up there. So kids shows, here are horror movies, and in between, if you do the average of our interest, like kids shows and horror movies are really, really strange things. And I get recommendations in the middle, which don't make sense. So it's not a kid show and not a movie I like to watch, not a movie my wife likes to watch. And I get these totally garbage recommendations. So that's also a challenge recommendation community is working on. Say, okay, this is the person can have many interests, how to represent it.
Thank you.